Okay, welcome to Stop One, the Climate Ready Landscape Tree Project. These trees are planted over at UC Riverside Agricultural Operations. We're looking into the performance of 12 species of rare trees to help add to the biodiversity of our current plant palette. I'm sorry we can't be on site together. As we discussed before, it's not the same as having a dialogue actually at the plot where you can see the trees, or you can perhaps even touch and smell the flowers. But we hope to be able to do that next time around. And I very much appreciate you stepping up to the challenge of sharing any questions you have in the chat room and hopefully enjoying and learning from this virtual experience. A couple facts that you as master gardeners know but serve as the premise for this whole climate ready landscape tree project are that landscape trees do indeed help reduce the impacts of climate change, and California has the lowest tree canopy per capita in the United States. Properly selected and maintained landscape trees can help mitigate climate change in a variety of ways. They can store carbon dioxide, they cool hot urban heat islands, they provide shade, reduce the need for interior energy, improve water quality through filtering of the root system, and they provide a habitat for wildlife and pollinators. And last but not least, they beautify our neighborhoods. Urban heat islands result in re-radiated heat that can greatly increase temperatures. This picture is in the heat of the desert in July. These are Ficus nitida. All species have their pros and cons. So these are typical parking lot trees. Not necessarily should we have a monoculture of these things out in the desert, but I will tell you this about them. They're a great shade producing tree, and in the summer, they can actually reduce the impacts of the urban heat islands substantially by reducing the temperatures 14 to 15 degrees. Even along the coast and in the Riverside San Bernardino area, you'll have, if not this extreme cooling, you'll have significant cooling of urban heat islands. I wanted to talk about a general difference, not in all cases, but in many cases, of higher tree canopies in wealthier neighborhoods and lower tree canopies in lower socioeconomic neighborhoods. So I'm going to show you one extreme and then the other extreme. And if you look at some opportunities we have, particularly in our high density urban areas where we have apartments, a lot of folks that are sharing smaller amounts of space, perhaps have the dark asphalt parking lots, may not have a park nearby, and may not even have trees in their parking lot. So the emphasis of this whole conversation as far as our research project is to help level the playing field so these situations aren't so disparate. This picture is in the city of Atherton, which is in San Mateo County. If you look at the dark blue, that represents a current tree canopy of 0 to 11%. You can see that that's a relative small area. Most of that area, you have a tree canopy between 23% and 89%. Our goal is overall in 20 years to increase our urban tree canopies to at least 23 or 25%. You can also see that the percentile of poverty incidence is very low in this community, and generally, residents of this particular community are healthier than in the San Bernardino tract, which has a 99 percentile poverty incidence, and the tree canopy by far and large averaging 11% or lower. There's some opportunities where we can work with cities, we can work with planners, with landscape architects, come together, work with the stakeholders, and try to right this wrong. So the goal of our climate-ready landscape tree study is to measure the performance of promising landscape tree species based on their drought and heat resistance, their low maintenance, their ability to sequester carbon dioxide, their tolerance of a wide range of soils, their pest resistance, their ability to provide shade. Again, they represent 1% or less of the typical tree palette, both from a street tree perspective and just the mapped neighborhoods that we randomly assessed. It's important to look at natives, of course, but it's just as important because of our non-native current conditions, which are expected to get even harsher, to look at adapted non-natives. So you'll see that the 14 pictured species here are mostly natives to the Southwest, but we also have the red push pistache, which is native to the Middle East and Asia. And then we've got the mulga, which is native to Western Australia. If you think back what's happened just in the last 20 years, the conditions are strikingly different. And the Joshua trees are actually seeding 400 to 500 feet above where they did 20 years ago. The seeds that are at the base of the plants are not living, and a lot of the Joshua trees that are even at Joshua Tree National Park are starting to decline and die. So we want to both look at biodiversity, and we want to avoid monocultures where we have just one or perhaps not a monoculture, but only 2 or 3 main species of trees that when you have a pest move through can be obliterated. So the selected finalists are native mostly to the Western US and California, but also, as I mentioned, Australia, Oklahoma, Texas, Asia, and Mexico. Here's a picture of a few of the trees at the plot. On the left is the Tecate cypress. We had some issues with that one. We actually had Phytophthora root rot. We're not recommending that one. It's not performing real well. We took some of the specimens out. The tree on the right is the Bubba desert willow. It's growing great. So that's one on our short list. It's also in our mulch study, and I'll be talking about that one in the next segment. I want to thank our partners. We've got these trees planted in parks as well as at South Coast Research and Extension Center and at our UC Riverside plots, but many community members and stakeholders and nonprofit organizations planted trees such as these at Woodley Park, which is depicted here, and several others. So the first step was to evaluate climate trends and exposures when making our plant selections. We used a reputable model called the CalAdapt climate model, and it has predictions for what's going to happen over the next 75 years as far as tumultuous weather patterns. So it's not just drought, but what's driving it is changes in our climate, up and down. Due to these higher temperatures, climate zones are expected to shift 1/2 to 1 zone warmer within the next 20 years. And this is the USDA zones, which are larger. So sunset zones actually are going to be impacted by perhaps 2 to 3 zones because the zones are smaller. So this is a really important element in the choice of trees that we need to make sure are hardy enough for the future. We used what we call a tree vulnerability matrix. We were able to map out the biological interactions, habitat, and physiology for selecting these 12 species. So they're wind resistant, they're also drought resistant. Shown on this chart is the difference in the relative evapotranspiration rates. This is an average over about 50 years, so it's not real time, it's historical data. Look at the difference in Palm Springs versus Riverside, and then the blue bar in San Francisco, where the cool season turf grass, which is the reference crop, as you recall, requires about twice the water in the Coachella Valley as it does in San Francisco. Riverside is between the two. So it's important, and you're going to learn a lot about ground cover and turf irrigation today. But being that most plants follow these normal bell curve trends, it's important in fall to reduce the amount of water that we're applying to our plants, to not overwater them. And then in spring, usually we see symptoms and realize that the trees are drying out, we need to apply more water. Our trees were irrigated in at 80% of reference ET. The second and third year, we gradually reduced the supplemental water to 50% ETO. And then in the spring, we turned the water off entirely. So again, there's a balance of how low can you go? Are the trees going to function when the water's turned off? Because if they don't function and provide the premise for what they need to help mitigate climate change, then the experiment is basically a waste of time. So there's a balance of saving water, but providing enough water so that the trees will perform adequately, if not preferably. So I'll ask you when we're going through these pictures to think about the aesthetics, and is it worth having, for instance, the Desert Museum flowering all right, but not profusely? And would that influence your recommendation to residents that contact you in your role as master gardeners? The picture on the right is one of the 140 California Irrigation Management Information Systems. And every few minutes, these things clock for 140 different climate zones in the state: temperature, solar radiation, wind speed, and relative humidity, which are the drivers for plant evapotranspiration. If you want to look more into the water requirements of landscape plant studies, we've got a paper that you can download for free. Or if you're more on the policy end of things, you can look into the Landscape Water Conservation and Public Policy paper. These are just 2 samples. There's several others that Don and Amir and his grad students, I'm sure, will bring up as well. So the second step was we identified promising species by also running our shortlist by local experts. And I mentioned before that we had compiled tree inventories and we cross-referenced trees for their rarity. So we transplanted the trees from 15 gallons. We added 4 inches of wood chip mulch. We irrigated trees in at 80% of ETO. The water's been off for several months now. We ascertain overall plant health and the growth and development. Here's a plot the second year. This was pre-COVID. We've got some resource conservation district and some city folks at a field day that you can see on the right. Nobody had masks, which is one of the ways we're going to date our pictures in 30 or 40 years. It used to be what house you might have had, or what condo you had, or what car you had. For 2020, it's going to be, oh, okay, the year of the mask. But you can see the trees are growing well. The mesquite, and then on the right is the Desert Museum. And it was still receiving, at that time, 50% of reference ET and flowering really, really profusely. I have a short video just to show you what the Riverside plot looks like. This was taken just a few weeks ago. The trees are 4 years old. To date, the results are that we've got some trees performing better than others. The silver tree isn't dead, it's a mulga. So that's just the color of the leaves. We looked at survivability, and certain specimens in the species of the acacia, of the Celtis reticulata, the Prosopis glandulosa, performed really, really well as far as survivability. We had a couple poor performers. Coastally, the ghost gum and the palo blanco just didn't hold up. So those aren't going to be further assessed. There were reasons that we believe it's more specimen determined than any kind of treatment or mistreatment that nursery or from a landscape perspective, the trees might have received, which is a really important distinction. The worst performers inland at the UC Riverside plots, again, are the Tecate cypress. It died due to Phytophthora root rot. You can see that on the photo on the left. And the gray is the mulga, it's doing fine, but the Tecate cypress on its left is the one I want you to focus on. And then a beautiful tree called the escarpment live oak. I differ with thinking that it should be knocked out of the study. Its survivability actually was more about the roots drying out in transit. And I like the tree. And the other sites and some of the parks, it's performing really, really well. So I think it was unfairly kicked out, but that's my opinion about it. It and the rosewood are the two largest trees, so they're going to need more space than the others. And that's something to definitely keep in mind when you're recommending one species over another. The best performers, coast and inland, if you're going to look at that larger group, are the netleaf hackberry, the Maverick Mesquite, the red push pistachia, and the island oak Quercus. The netleaf hackberry is a California native. It's deciduous. It grows to about 35 feet high, 30 feet wide. It attracts over 30 species of birds, and it's not a showy flowered specimen, but it's more renowned for the fruit. All of these are drought and heat tolerant as well. I'm just going to go over the Maverick Mesquite briefly because I'm going to zero in on it on the mulch study. So keep in mind that it's performing really, really well and is thornless, which is the attribute for this particular mesquite called Maverick. And I love the pistachia red push. It's got the spring growth that comes out brilliant red. Sometimes you get a second flush that's red about 4 weeks after the first flush. Really, really pretty tree. And I'll talk about it more for the mulch part of the presentations as well. Again, these trees are going to look a little different when the water's turned off and they're truly under drought. The island oak is a beautiful tree. It's got a brown acorn, Quercus tomentella, really, really pretty tree. This one gets large, so it's going to take a lot. So the island oak is native to California and Mexico. It's evergreen. It's very drought tolerant in our studies, but in the literature, it's still reported as only somewhat. There's a specimen tree of the species in Santa Barbara that's over 50 feet tall and 60 feet wide. And it's a great species if there's enough room. So I'm going to stop there. There's probably some questions.
Yeah, we have 3 questions. One of them I think you answered, which was which ones are California natives. So I know you went over that earlier, but then there was a question that said, why so many exotic species? Are non-natives really the best choice for biodiversity? That was one of them.
Okay, that's a great question. And I'd love to discuss that a little bit. We hardly have a native climate anymore, especially in our neighborhoods where we have the re-radiated heat off asphalt, and with more people, a larger population, the climate itself is hotter. Mostly the burning of fossil fuels in urban areas is contributing to more heat. So if you look at a California native that performed well 200 years ago, not necessarily does that same species perform well in 2020 or in the next 75 years when we're looking at a downward spiral due to climate change of adverse conditions. So the goal is, yes, to definitely preserve biodiversity, and particularly those native species that will continue to grow well, at least well enough, even if they may not thrive like they used to. But we're also in the same vein of preserving and even expanding biodiversity, we're looking at getting away from monocultures and including non-California and even non-Southwest native plants that have all the attributes and also the important newer attribute of performing well under adverse conditions. So as master gardeners, and many times you are asked to provide a useful landscape tree, shrub, ground cover, turf palette to homeowners that contact you that would do well in their microclimate zone. And if they want to go all native, and that's happening more and more, then I'm certainly not suggesting that you reiterate what I have just said. But if appropriate and it makes sense, you might want to bring into the conversation the fact that if in their microclimates natives aren't possible, California natives aren't possible, to widen their scope and breadth a little bit as far as their flexibility on other highly performing plants. Anything else in there, Maggie?
Yeah, I think we have 4 more questions. I'm not sure if you can answer this one. Do you know if the mesquite pods are edible?
They, on that one, maybe. I'm not going to say yes, because on its forefathers, yes, but I'm not going to go there.
Okay, and then another one is, does the island oak have GSOB or gold spot oak borer concerns like there are in Idlewild and Oakland, and you know if that is a susceptible species to the gold spotted oak borer, the island oak?
It's not on the short list yet.
Okay,
And it could be because it's rare. So in a lot of cases, when you have a short list about shot hole borer, which is another big one, what's resistant or susceptible? Well, if you're just looking at numbers of trees, that's a whole different thing than looking at the percent of a species that may show some damage. So the verdict is not out on all of these because they are rare, but that one does not pose a problem that we know of at this time.
Okay, very good. And then is this oak a black nut species?
It's a brown nut.
And then a couple more. Some mesquite become invasive. Do we know about the invasive risk with the Maverick?
The Maverick was chosen because of its quality, that it is not invasive.
Very good. And then they wanted, will a list be provided that they could easily share with the public of these in the future, perhaps?
Yes, we'll have the slides provided. And as we talked about earlier, hopefully some hands-on field day where we can actually be in the same place at the same time, see the trees, touch the trees, not stomp on them. We don't want to impact the soil, but meet the trees.
Okay, then there's a question that says, we had a landscape architect talk about the improvement of neighborhood pride and health with the greenification of at-risk neighborhoods. Are there efforts to repeat this for Riverside, LA, and San Bernardino County?
Excellent question, and yes, we're doing a lot in that vein. Also, because of COVID, our Climate Ready Landscape Trees and Trees for Tomorrow workshops, in which we were inviting stakeholders, government officials, city managers, city planners, landscape architects, along with master gardeners, to have a conversation of how can we increase tree canopies to at least 20% over the next 20 years to help to reduce the risk of this adversity. And we're going to be handling that in a virtual way, a virtual format, since we just can't be meeting face to face because of the COVID situation. The afternoon of these Trees for Tomorrow workshops is going to include a lot of sharing across professions, and then some subgroups to look at some of these species from this study and others. There's been a lot of work in the Phoenix area on a similar study. And one of the findings of that is, why are we using black asphalt in neighborhoods?